world! Welcome back to the best damn tutorials on programming electronics and robotics in the badass foundational C language. We're building something very special here, but I can't tell you what it is quite yet. You all are very incredible for studying this very complex skill. It is difficult, so if no one else cares, know that I am cheering you on. You will have more failures than successes, but your successes are huge compared to the many tiny failures. Thank you for all your encouraging comments on YouTube and Instagram and all the tips over on Odyssey. Have you seen Odyssey yet? Go check it out. No more waiting to get monetized. There's a referral link in the description below. This is going to get better and better each video, and I'm very happy to teach you what I've learned so far, because this stuff isn't easy, but the world is craving the knowledge. These foundational tutorials are going to help you bring your ideas to life. So get fired up, because today you're going to learn a quick way to use a push button to glow your LED on and off. If you haven't already, go back and check out my video on how to glow an LED with C language first. So here we have our breadboard. Same layout as before, and now we are going to add a simple push button along with our code. The overview of the concept of this code is that a pin is connected to the button, which is turned on with electricity, and the loop is constantly looking for the electricity to go low. As soon as you push that button down, the metal bridge inside the push button connects the pin's positive side with the ground side of the power source. This starts to sound confusing, so let's head on over to our code. Here's the code. It is the same code as the LED glow video that I showed you. It's the same code. I've given it a new name and saved it as a different file with the .c at the end. Make sure to include that. And I just put in this name, helmet, and then capital LED, and then new button.c. I put in the new because this is similarly titled as my other code with the push button for the helmet. I just did it a little differently. That one uses an interrupt, and I was having trouble with the interrupt because it uses a timer, and the timer for the LED, it was conflicting. I was trying to figure it out, so I just decided to do it simpler. And we're going to do a debounce. So what a debounce is, basically you push the button down, and then it's going to check to see if it's still pushed down after a certain period of time. And if it still is pushed down after a certain period of time, it's going to execute your code. So in this case, we push it once, and then it's going to check to see if it's still pushed after a very short amount of time. If it is, then it's going to trigger the glow on code. And then after that, we're going to have the status of the button press. Say it was turned, the button press was off. It wasn't pressed. That's the state it's in. It's off. It's like 0. And then when we start the code, that value is 0. And then when we press the button, it checks to see if it's still pressed. If it is, it glows the LED on, and then it finally changes the status of the button press to 1, meaning, you know, it's on, it's been pressed. And then when it goes back through the loop again, it knows that the status is on. So then it's going to look, when you do the button press again, it's going to check to see if it's still pressed, and if the state is 1, which is, you know, it's been pressed before, it's going to do the opposite. It's going to glow off. So that's all it is. It sounds confusing, but I wanted to give you an overview before I go through this really quickly. So we have our include files, like I said in the previous video. These are the same include files. They're very basic files. We have our defined debounce time. So instead of typing the actual debounce time of 1000, I just put it in as debounce and then, you know, capital T after that. So debounce time. So I can type this in and put it into the code down here instead of typing the actual number. All right, and here is the previous code: delay, LED delay A, LED delay B, and I just had 2 different predefined times for the delay to make it look a little bit better. So when it glows off, a shorter delay makes it look a little bit better. That's just the way the brain perceives the glowing off. It's just the way it is. So it doesn't perceive it linearly. It doesn't perceive it in like a, you know, like a straight line, like it decreases perfectly down or perfectly up. Your brain interprets the glowing effect in percentages, so that's why it looks better if you make the delay shorter when it glows off. So let's go ahead and move down to the actual debounce code. So when I push my push button, which is connected to pin PC5, I just decided to use that pin. You can use any input output pin that you want. This is just one that I like to use for my push button. It doesn't really matter. So I give it this this setup, static inline void, and then I said init timer, and this just means initialize the timer. And the previous code, I had it labeled as something different. It was start timer. So just make sure that your titles match. It doesn't matter what you give it a name, but whatever name you give it up here, you're gonna have to make sure that name is the same down here when you actually call it to the stage in your main. So just keep that in mind. All right, there's 0 parameters that I need to work with, so it's just void. It's nothing. So the actual name of it is init timer, and then these 2 parentheses, which are gonna be called down here. When we turn on the chip, it's gonna go through the main first, and then it's going to go through the loop. So that just turns all of this on. So we have timer counter control register 1A, and we write that to on here and on here waveform generation mode 10 and 12. In the datasheet, like I said in the previous video, that accesses timer 1 in fast mode. And then we have our prescaler. It's going to divide by like 256. That's in my previous video as well. And then in that register, we're going to turn on COM1A1, and that's going to set our output. Okay, so going on to the actual debounce, we have an 8-bit variable, unsigned 8-bit variable, which we're going to call debounce just for simplicity. There's no parameters to take into account. We open and close our brackets here and here. So in between this code, we're going to write if the bit is clear on pin C, PC5. So these are the parameters that we're taking into account with the bit is clear function that's already outlined in this header file. It does it for us. Somebody's already created it and they've titled it bit_is_clear. So if you say if bit is clear on this pin bank, pin C, specifically PC5, which I'm using, you can use anything else. If you're on the B pins, you say pin B. If you're on whatever else, you need to make sure you change it, otherwise it won't work. So I'm working with pin PC5, and if it's clear, it's going to have this delay in microseconds. That's what US stands for, microseconds. And the amount of microseconds you could type in here, you could say, 50, 100, 1000. 1000 seems to work pretty well. So I said 1000, and I gave it a label debounce time. And this is just good practice for writing code, to have a predefined value that you're going to use multiple times, and you just give it a name. That's it. So that's what that is. You don't have to do that. You can write an actual number, and you can play around if you want. But 1000 seems to work pretty well. So it's going to see if the bit is clear on that pin PC5 that I've chosen, and then it's going to delay, and then it's going to check it again. It's going to double check it to see if it's still pressed down. That's what this is doing. It's just double checking to see if the bit is clear twice on that pin, if the electricity has flowed out of it on that pin. And it's going to delay again, and then you don't need to worry about the rest of this. This is just it finalizing out. Don't worry about that. Return 0 is the same return 0 at the end of our code. Our code never really gets down to this point. Like I said, it's not worth covering, but just write what I have here. This is how you write a debounce code for a push button. And down in our main, we have the same code as before, so don't get confused. Just look at my LED glow tutorial if you need to. I'm not going to go over what we already have here. Just remember you need to call your timer that you set up by its appropriate name that you've chosen for it, and call it to the stage like this. Set your pins for output for the LED. It's going to send out electricity. So this sets the whole, this goes into the data direction register B, so all the B pins, and then specifically it turns on PB1. And then in port C, we're going to turn on pin PC5. And then we have this new thing called unsigned 8-bit variable. It's an unsigned, so it's not positive or negative, it's just a number. If you do a signed one, it takes up more memory in the chip, and we just don't need it, so there you go, I just taught you it. So an 8-bit variable that's unsigned that we're going to call button state, because we need to remember if we pushed it to glow on or if we pushed it to glow off. That's what this is. It's a placeholder for that. So we're going to set it to equal 0, so it hasn't been pushed yet. And in our loop, we're going to say if the debounce happened, so if the electricity it flowed through pin PC5, the bridge was gapped in the push button and it flowed out of pin PC5 and went to ground, and that bit is clear, then it's going to say if the button state is equal to 0, like if it's exactly 0, so if these two conditions are met, then we're going to do the glow code. Pretty simple. And then we're going to change the button state to 1. So it was 0 when we started it, right? When we started our main, it goes through main once, it sets all the stuff that you want to turn on and turn off and set up all your stuff. So it sets it to 0, and then it does the debounce, and then it changes the button state to 1 after we've closed that door for this code. Remember that. And then, you know, if you need to put your button state equals 1 in, like right after you do the glow, the actual glow. All right, so just make sure it's within this door. It's in this door, but it's after this door. And then you close that final door there. And then if we push it, the button state is 1. So now we just do the opposite. So we use the same. You can copy paste this. If debounce, and if the button state is equal to 1, which we set it to, then it glows it off. It decreases the amount of time that it's on. So it looks like it's glowing off. So it's turned on for shorter and shorter time. And then we have the same glow code as the glow tutorial. And then we change the button state to 0. So we told it, oh, it's glowed off. So now it's back to 0. So then it's going to go back in the loop. So every time you push it, it's going to set it to 1. And then you push it again, it's going to set it to 0. And then you push it again, it's going to set to 1. Push it again, it's set to 0. So this is a very simple way of having the chip remember if you glowed it on or off. You just flip it to 1 or flip it to 0 with this kind of this placeholder, this variable that we call button state. You can call it whatever you want. And make sure you close all your doors, and that's it. That's the entire code. So it's about 64 lines of code with white spaces, so well under 60 lines of code, which is not bad. And there's other ways to do it. There's a way to do it with interrupts, but that gets a little more complicated, and we'll have to cover that in a future video. So what kind of use could this push button with LED play? What in the world could we do with this thing?